This is Unit 4.9, El Nino and La Nina. So you may remember from previous screencasts, we talked about surface gyres. So these are large-scale water circulations. Um, they move clockwise in the northern hemisphere, counterclockwise in the southern hemisphere. They're caused by the interaction between winds and surface water in the oceans. Now, another thing that happens when these surface winds are pushing the water, they're pushing them sideways, like along the surface, but then somewhere along the way, they have to circulate, right? As they get to colder areas, they sink, and when the water goes deeper, it becomes more nutrient rich. It picks up um, nutrients that have fallen down like deeper into the ocean as organisms have died and decayed. But then when that cold water reaches the coast of a continent, it tends to move up and upwell and becomes water, and that keeps things circulating. So we're very concerned about upwelling, right? The upward movement of ocean water. It mixes the water, it brings nutrient rich water to the surface, and that can support large populations of plankton, fish, and fish eating seabirds, where the water is both nutrient rich and the surface air is warmer. All around the world, we see this nutrient upwelling along different continents, different parts of continents. So, all these areas that are highlighted in red tend to have nutrient rich upwelling of colder, deeper currents. So we see upwellings, like we said, along the steep western coasts of some continents. We're concerned with El Nino and La Nina, specifically around South America and Australia, and then parts of North America. So, like we were saying, winds blowing along the coast push surface water away from the land, and that draws water up from the deeper areas. Another diagram here for your perusal. You can see the wind kind of moving crossways in this case. But as the warm water gets pushed away from the land, cold water upwells, and that's where the fish like to be. Even more upwelling, right? All along California, this is what is happening. And you can see the temperature differences here, where it's colder near the shore, and then it actually goes warmer as you go offshore away from the upwelling. So, what is this El Nino that everybody keeps talking about? Well, periodically in the Pacific Ocean, the upwellings are changed by weather patterns, where the tropical trade winds weaken that are moving from east to west, or even reverse direction. And then the Western Pacific warmer waters actually move towards South America. So, previously all these diagrams, we were talking about water moving from the continents toward the ocean. In this case, the warmer waters move from the ocean towards the continents. And what happens is the normal upwellings that would happen of the cold, nutrient rich water do not happen, or they happen to a lesser degree. So we have a couple different diagrams here that show normal conditions versus an El Nino event. So notice under normal conditions, you have the warm surface water moving away from the coast. But in an El Nino event, all those nutrients get left at the bottom because it doesn't push nearly as far up as it does normally. So there's decreased plankton concentrations, which results in lower fish populations, which means lower bird populations, which means less fish for fishermen. Another way you can look at it is in this diagram. So again, the normal year, you can see the warm water heading west away from South America. But in an El Nino year, the winds are weak or even reverse direction, and then there is less cold water and less nutrients. This has the interesting effect of making the winter warmer in the US as well. So the effects of El Nino, like we said, we see the decreased nutrients and decline in fish populations along South America. And this can also alter the weather in places like Australia and Southeast Asia, any Pacific islands in the Indian Ocean, like in Indonesia. That weather gets affected also. So the air in Australia becomes warmer and drier, right? Because now um, the warm water is moving in the opposite direction. South America, like things get wetter and warmer, but also less nutrients for the fish. Again, you can see drier weather in Australia and Indonesia, uh, wetter weather in South America, but it affects the northern hemisphere as well. More diagrams. You can see in the normal conditions how cold water comes up closer to South America. In El Nino conditions, the cold water is suppressed. Now there is also La Nina. So we were talking about how the water gets pushed away from South America toward the ocean where it warms up. Well, that can also be accelerated or exaggerated, and that's what's called a La Nina event. So in this, it cools some coastal surface waters and brings back the upwellings. Um, and some effects of this, which are kind of interesting, we see more Atlantic hurricanes in the La Nina event, colder winters in Canada and the Northeast, more wildfires, southeast, southwestern US, there are drier winters, wetter winters in the Pacific Northwest. Southeast Asia in El Nino gets droughts, but in the La Nina, Southeast Asia gets torrential rains. And somewhat specifically, we get lower wheat yields in Argentina due to La Nina. There are lots of videos that we can watch about this. There's this guy from PBS. There's this one, which is pretty straightforward. And then a more simple animation from the Met Office. And then also one from National Geographic. So those will be available to you, and maybe even watch one in class. All right, that is Unit 4.9, El Nino and La Nina. Please let me know what questions you have.